Greetings and salutations. I, Sunandan Kapoor, serving as Vice Chairman for the Krishna Group, am honored to be a participant in today's all-important event. The journey for Krishna Group has been a highly rewarding one. From one location, one plant and one product in 1993, armed with goodwill, faith and invaluable guidance from MSIL and SMC Japan, we today, through our 37 facilities across the nation, are able to create employment for 10,000 plus Krishna Group family members. For SKH specifically, the journey started in 2006 on the back of MSIL's support. Our people have shown us that when we fall, we always have the choice to get back up again. On that note, I thank you for your attention and your time, and once again, give way to the SKH Metals team to share more on quality control measures through FMEA.
Quality being the topmost priority for any organization, it becomes very imperative to identify such process equipment that produces defect-free parts. In spite of everything, there is a high probability that the defects may generate. To eliminate that possibility, Process FMEA is the tool that helps us to identify risk proactively that could lead to defect generation. Let's go through the journey of Process FMEA at SKH.
We followed 3D concept for PFMEA, that is planning, execution, check and action based on results. We carry out PFMEA for 100% new developed parts through CFT formation, identification of failure modes, implementation of actions and standardization of documents.
The cross-functional team comprised of experienced persons from production, quality, maintenance and development. Multiple brainstorming sessions are carried out to list down various failure modes, which are part and process study to understand critical dimensions and quality parameters. Past defects which have occurred in previous model so that actions can be planned. Identification of failure modes due to change point, that is new process involved and new technology in parts. Possibility of human error to identify man-dependent process and risk involved. PFMEA draft document was prepared and jointly reviewed along with MSIL team. The feedbacks were incorporated and actions implemented are jointly verified by MSIL. In one of the case, we identified some unanticipated failure modes. These were wrong assembly of part like double part welding. Second is mix-up of similar looking nut. The third one is process miss like hole miss. Feedback from operator was also captured. The actions taken against the identified failure modes are implementation of sheet thickness logic PY for double part welding. The second is implementation of LVDT sensor to avoid wrong nut welding. The third is implementation of hole checking gauges to avoid defect due to hole miss. The last and most important aspect is standardization. We keep PFMEA as a live document. Based on final PFMEA, process control plan, work instruction and inspection standards are made and training is incorporated to relevant team members.
PFMEA indeed is a very effective tool and it helps to reduce the defects and also overcome all the quality issues in the organization. I'm indeed thankful to MSIL for their support in implementing PFMEA in our organization, and I'm very confident that the results of the same are going to be very healthy and all the parts will be defect-free in times to come. Thank you.